All right, I guess we can start. Okay, so today we have a wonderful, very exciting, very discussion-oriented talk prepared for you guys today. We'll be looking at labs, so the role of the lab, the past, the present, and the future. And I'm your host for today, Nikita Burrows. This was prepared by Alina Moon as well as Vicente Tacular. So thank you guys so much for helping to put this all together. And I would also like to thank our panelists who are here to discuss with us. Who we have for our discussions today is Brittland DeKorver. So you could give a little wave, yeah. Coming from Grand Valley State University, some of the work that she's done involves general chemistry and upper level students' perspectives or views on the goals of laboratory work. So really interested in hearing her perspective. We also have Joi coming in here, Joi Walker from East Carolina University. I saw on Twitter that you recently just got promoted tenure, so congrats.
Thank you.
Yes, some of the work that she's done looked at investing inside of laboratory courses inside of GCE, and a wonderful article in C&E News looking at questioning the value of general chemistry labs. So we have some very, very thought-provoking topics to go through today. And then we also have Michael Seery here, coming from the University of Edinburgh. Some of the work that he's done looks at establishing the laboratory as a place to learn and do chemistry, as well as a framework for learning inside of the chemistry laboratory. So for today's talk, we kind of want to look at a bird's eye view of the laboratory. We kind of want to get a sense of what is the purpose for the lab and also for varying student populations. We also kind of want to look at how can we then achieve that perceived purpose, and then any potential alternative ways for us to achieve that purpose. So that's kind of like the big overscoping issues for today. But I kind of wanted to start off with something that was said before I was born. It's a quote from Hostin and Lunetta in 1982. And it says, in contrast to other modes of instruction, there is insufficient data to confirm or reject convincingly the importance and the effectiveness of the teaching laboratory. So let that sink in a little while. That was said from way back when, at least for me. And I want us to kind of start off with the question, why do we do lab work in chemistry? So any of our panelists can take that.
I think Michael was going first.
Yes,
so.
I think I can kick off. So I guess we do lab work in chemistry because we're chemists and we've always done lab work. It's what chemists do. It's how we define ourselves. And Nikita, you went back to 1982. I can take you back to 300 AD when Zosimus of Panopolis, the early alchemist, was one of those first people really bringing together this kind of idea of the artisan craft of working with metals alongside the Greek philosophy of thinking about why things are happening. Okay, so the doing and the knowing, and that doing and knowing, I think, is a place in labs where a place that labs can really facilitate. And obviously, as in the modern era, from the 1800s and so on, the idea of what a chemistry lab is in our curriculum today really got established by people by Justus von Liebig in Eastern Germany, and that was very influential on the US model of chemistry education. So that's the bit of history. But I'm sure, maybe not, but I'm sure your university administrators won't be too convinced by Zosimus of Panopolis, so we might have to come up with a modern reason. And for me, I think we need to come up with we need to define as educators ourselves, what is the unique, distinctive purpose of labs from a pedagogical point of view? What is it that we can do in labs that we can't do somewhere else? And for me, I think that's the idea as the labs as a place where we learn how to do chemistry, not where we learn chemistry, but learn how to do it, learn how to take what we know and put it into practice, what people have called the syntactical nature of science, or sciencing, this idea of taking what we know and doing it in practice. So in answer to your question, why do we do labs in chemistry? I think we should do labs in chemistry because there should be a distinct place where we can teach in a way that is very difficult to otherwise do so. So that's my past, present a little bit.
Thank you, Michael, for taking us through a little bit of history on that. I want to build on what you said about that is we do chemistry labs because labs are where chemistry is done, and say that doing chemistry is not a monolith. There are a lot of different ways to do chemistry, and chemistry means a lot of different things to different people. And depending on what kind of chemistry you do, you might have different ideas of what is important for lab. Lab cannot be all things to all people. It has to be focused in what are the important things. And so I think that looking for a singular purpose for lab is a dangerous idea. There is work out there that surveys a pretty narrow range of faculty, looking at what do you think is important for your lab, and even in the same set of courses, faculty don't agree on what is important about lab. And if you think about, especially like a general chemistry lab, that is one of the courses that has the most instructors, right? Because due to the physical constraints of lab, you are capped at a certain number of bodies per instructor in a space. And so we've got all of these instructors who may have very different ideas of what is important for lab, all trying to teach exactly the same thing. And so my question is, are they teaching the same thing? Because we should be driven by our goals, right? So if some instructor has private goals that are not quite aligned with the goals of the curriculum, that's where we have some of these conflicts, and could be one of the reasons why that Hosteen and Lunetta quote comes about. Like, how can we say that lab is achieving our goals? Well, maybe we are holding these conflicting goals as instructors. And so anytime any curricular changes are made or a curriculum is set out, it's really important to say, what are the very specific goals of this curriculum? Is it to have students work with other students? Is it to manipulate physical equipment? Is it to learn concepts about chemistry? Is it to learn scientific inquiry? We need to pick the goal for this part and then make that curriculum focused toward achieving that goal.
Well, I mean, I'm gonna say what I was gonna say, but I'm not sure. So I've been doing research on labs for 10 years. So first of all, I take a little bit of umbrage at the fact that there's no research on lab. I have 12 to 15 papers published on what we accomplish in the labs that I design and that I do. So there is research, and it is a very clearly defined curriculum. And I think what we are, or I know what our goal was to engage students in scientific practices, moving away from scripted labs where they're told exactly what to do, introduce some nature of science, expose them to more authentic experiences. And I'm gonna not get into a whole lot of that. I do think that we have, and we'll have a lot of different populations that we're dealing with. I think, I guess, the idea that different instructors are teaching courses differently, that's ubiquitous. There's not a course at the university that a different instructor isn't teaching differently. But one of the things I think I'm trying to do and that we're thinking about here at ECU in the labs is to see what we can do to make particularly maybe one investigation or some parts of the lab maybe of more application to other students. For example, there was a very good publication in the Journal of Engineering Education where they simply took a simple change to the density lab where they looked, introduced the idea of specific strength over density. Well, that's very applicable to engineers. So, this was done purposefully to try and add a component to the lab that was useful for engineers. But I'm of the belief that we do lab work to allow for, as Michael said, for other things to be done in chemistry. And the things we do is students design their investigation. Students engage in argumentation. Students do their data analysis on their own. They write their lab reports. They engage in peer review. All of these are aligned with the framework standards.
Okay, so from Brittland, I'm hearing you say something along the lines that, each instructor has their own specific set of goals that they hope to achieve inside the lab. But it kind of also sounds that from Joi and Michael that maybe there is some type of core thing that we want to be achieved inside of the lab. Have you guys started picking at what is some type of core thing we want the lab to achieve?
I want the students to be able to engage in science practices. And I just listed them all. I see lab as the place where we can do that.
Yeah, I think I'd echo that. Our focus here has been on students learning about the scientific process and how they engage in it. I should qualify my remarks in that most of the students I deal with, all of the students I deal with, are chemistry majors. On Brittland's point about the lab goals, this is probably something we'll come back to later. But this is, for me, is one of the fundamental problems with laboratory instruction. And David Dowd's book on Elizabeth Hegarty Hazel's book on labs in the 1980s or something had a lovely quote in it that said, it doesn't matter what's in the lab manual, it doesn't matter what's in the QA handbook or whatever. What matters is what that faculty member on that day thinks this is what the lab is about. And I think that's why conversations like this are so important, because until we sort of come to a consensus about what a particular lab course in a particular institution is aiming to achieve, and everybody kind of aligns with that, it's really tough from a student perspective, because they've got a whole mixture of expectations on them. So I think that idea of aligning to a goal, maybe not a particular goal that I think of or other people think of, but a goal that program team decides is important for those students. That's really the first nut that needs to be cracked. So sorry, there's a very long answer to say science practices as well.
May I bring something in? I'm not a panelist, but I'd like to say something very simple about this. Is that
Sure,
okay?
Go ahead.
Hi there. I'm fortunate enough to work with Dr. Burrows, and I am not a chemical education specialist. If I need to know anything about that, I speak with her. But what I'd like to say is it's very simply, chemistry is an experimental science. And as I think it was Joi said, it's where you bring it home in terms of getting students to think as scientists do. Because, and furthermore, it's a place where we can break the tyranny of what is inevitable for lecture classes, because all the stuff in the textbook came out of laboratory work. And it had to come from there. It's not like a history course or an English course where somebody just wrote down these rules or what happened in this year and that year. Things had to be figured out through a lot of toil and sweat. And if we can bring that thinking into laboratory courses, we're bringing it home in what it really is to be a scientist. So that's what I wanted to throw out. Really simple. Chemistry is an experimental science, and that's where all of the stuff comes from, and students should understand that.
Okay.
Thank you
so much, Bill. But we are focusing a little bit more on our panelists kind of talking for this session, and then we'll move into it. Yes.
I'll keep quiet now. Thank you.
Nikita,
Okay.
I just wanted to follow up real quickly also on this idea of I mean, I've been implementing argument-driven inquiry in labs for 12 years now. And I've observed TAs, I've observed tenured faculty, I've observed instructors, I've observed adjuncts, I've observed undergraduates teaching the curriculum. Everybody does it a tiny bit different. No one does it exactly like I do. But the format, right? The students are still having to design a lab. They're still engaging in argumentation. I mean, the components are there just as they are with any curriculum. So, you know, I'm just saying, I mean, I've observed and videoed hundreds of hours of lab instruction. So I don't see a huge variation in what's going on.
I want to follow up on some of these ideas and incorporate, there was a question in the chat about when is it appropriate to use cookbook style labs?
Yes.
And if you found yourself agreeing with what Bill said and what Joi and Michael have said, that lab is a place for experimentation, then I would say that would not be a place for cookbook style labs, and that you would be needing to put in front of your students that sort of scientific inquiry process that Michael and Joi have both advocated for. If your goal is, I want them to be able to follow directions and use scientific instruments or materials, then that's when you would steer more toward a cookbook style lab. But you have to take a look at what your goal is. If your goal is experimentation, then the students, like Joi said, have to be designing their own experiments. Otherwise, it's not experimentation, it's following steps. So if you are saying to yourself, yes, it's about experimentation, then make sure your students are having that authentic experience of engaging in science practices. So whether or not a cookbook style lab is right for you or for your students depends on what you think or your department thinks is the purpose of lab.
So that actually is a perfect segue into one of our next questions. So what do you think students gain from doing lab work?
Are we doing, Brittland, you were going to talk on this first.
Sorry, I lost track of which one we were on.
I think you skipped did you skip a question? Anyway, it's all right.
Well, that question kind of segued into it.
Sorry.
So
We're just trying to follow along at home.
yeah, we'll get back to that second question.
This topic is really near and dear to my heart because some of my research with Marcy Towns was about students' experiences and what students believe that they gain and why they do lab. So like Joi, I spent a lot of time videoing lab experiments, students doing lab, and then I interviewed them afterward to talk about it. And what I saw is that it really depends on the curriculum, what students say is the purpose of their lab. And if the students are being asked to do more of those science practices, then they buy in and say that that's what is important about them being in lab. But if they are doing more of a cookbook type thing, then their focus really shifts. And not to say that students don't share this focus in the more inquiry-based lab styles, but across the board, I saw students who said that they wanted to do what they needed to do to get the A and then get done in an efficient, timely manner, right? So they are learning these time management skills and how to divide up tasks so that everybody does what they're most confident and comfortable with to get done as quickly as possible. So I observed students, and this was like one of the scariest things, chemistry majors, good students, successful A-level students who do work in multiple research labs. And they told me in their senior year, they said, I never learned how to use a volumetric pipette because the lab partner always did it instead. And so if we think that students are supposed to learn these hands-on skills, right? So that's one of the things that people say is the purpose of lab a lot of the time. If we design the curriculum in such a way that a student can make it through multiple research experiences and all of the coursework in a major sequence, but not use a pipette, which I think that most chemists would agree is kind of one of the central pieces of equipment that we would want them to understand and be able to use in practice, then the curriculum is not aligned with the goals, right? And the student's goal was not to learn how to use a pipette. It was to not worry about messing things up. And so whoever was working next to her in lab would pipette for her because they were more proficient at it. So students are always trying to be as efficient and manage things as carefully as possible to do what they need to do and make that grade and suffer as little discomfort as possible, which is natural, right? We don't want to be uncomfortable, but learning is uncomfortable. So a lot of times, if our curriculum doesn't push the students into that discomfort, then they won't learn what we're hoping they will learn.
So one thing I want to point out that, I don't think we need to, it's not an either or. I can tell you with our curriculum, the first activity the students do is based on a cookbook lab. I simply take the cookbook labs, take some of the scaffolding out of it, but not a lot, just depends. And we call that, it's an in-lab pre-lab. And so they learn to use the pipette. They do it individually. They all do an individual titration in their group. So I think, and this is one of the things that I think is why I've been possibly more successful in implementing transformed labs here at ECU and at other universities, is we still do the lab that teaches them to use the technique. We still do the lab that teaches them to use the spectrometer. It's just the following week, they get an actual problem to solve with that equipment, and that's the inquiry piece. In terms of students wanting out of lab on time, my colleague John Grooms in his dissertation, he was looking at students' ability to engage in social science issues, and he was comparing the students at the community college I was at the time, students in ADI labs with students that were in very traditional scripted labs. And one of the things he noted, and this I think is consistent with what Brittland's saying, is that in the traditional lab, they had 180 minutes and the average time they spent in there was 95. In the ADI labs, they were there the whole time. They don't leave, they're busy. I don't have this issue of, can I get out of lab fast? We have to tell them it's time to go. So I think Brittland's right. It's a matter of making the goals clear, right? The goals are clear that we want to see what everybody else did. We want to understand the process. We want to understand the data. So, and again, I have 15 publications on what students get out of labs, so I don't need to go through all of those, but you can read them if you want.
I've read them all, Joi. I should say I'm feeling very anxious here because Brittland and Joi have both inspired my work so much. So I'm feeling like sort of a little fanboy here listening to them. I mean, I think I'd echo what they've said about essentially diversity. I mean, we're not talking about sort of I think monolith was the term Brittland used earlier. So in my case, I'm talking about students who are, when I talk about curriculum, we're talking about over 5 years. The iterative development of students over that time. And of course, early on, we're focusing on trying to get core skills built in. It'll be very much recipe type labs there because we want their focus to be on the skills development, not on the kind of experimental process. But then as that confidence builds, we essentially fade away the recipe and roll in some inquiry, until the point for us in the UK system where they do a final year research project, an undergraduate research project, the ultimate inquiry. So that kind of process is designed so that students come in with little to no lab experience and leave as functioning, practicing chemists in how we sort of define it traditionally. In terms of what students get, well, a lot of our research here has been on the sort of student experience of lab, especially in these environments where they have to start learning experimental design, usually midway through their 5 years of study with us. And that, I think Brittland mentioned, is a pretty tough process for them. This idea of learning how to experiment is quite tough, needs to be heavily scaffolded. But what does come with that is a sense of understanding from their part of what the scientific process is. And we have had students tell us and talk to us about that feeling of being a scientist, almost a sort of proto-scientist, this sense of, oh, I'm doing something where I've experimented and it mightn't have worked, but I was able to make some conclusions on that. And that's been a real gain for us in terms of really thinking about how we build in experimental design into our curriculum. So that's probably the main thing that we're looking for students to get from lab work, that understanding of experimental design. But as I've been waffling on, there's so much underpinning that knowledge about how to do techniques, understanding about just basic scientific processes in the lab. All these bits have to feed in so that we can build up to that overall process.
So, sorry, go ahead, Brittland.
I just wanted to follow up on what Michael was saying about scaffolding, and someone in the comments, I saw a comment about how do we get students comfortable with some of these inquiry things, because it is uncomfortable to not know what happens next and to try something and be wrong. And I think that that goes back to some of the observations that Joi has shared about things like argument-driven inquiry and a lot of the PBL methods. And I think Science Writing Heuristic 2 has a lot of evidence that it actually makes students feel better about themselves in lab, that they say that they enjoy lab more, that they are showing a greater degree of engagement, that they want to be there, that they like what they do, they're proud of what they do because of doing some of these scaffolded inquiry-based approaches. So yes, there is that like pushback on, oh, this is hard, I don't know what I'm doing. But overall, at the end of things, students have a lot of these positive affective or emotional outcomes that are not necessarily like specifically intended by the whatever pedagogical method you're looking at. But what is not present in cookbook labs is that benefit, right? Students do not like cookbook labs. They do not feel good about themselves after doing cookbook labs. They may be satisfied that they got done in the half of the time instead of staying the full time, but it doesn't increase their own confidence or self-efficacy as a chemist.
ECU, long before I got here, actually had a UTA course, which is fantastic, and I get to teach it. So I get undergraduates that want to be the teaching assistant in the lab, and they work with either a graduate student or an instructor. And so I call them, they're my Dumbledore's army, right? They're in there telling me what's going on. They're so awesome. But one of the young women, and at the end of the semester, I have them do a project on something they think would be useful for other students in the lab. And I had a student, and I'm so excited, and she's still working on it. She said, I want to make a video to tell everybody ahead of time that it's going to be okay, that they're going to be confused, but if they'll just stick with it, it's going to be okay. And I was like, wow, I would just love to hear you do that, even if it's just for me. But I thought that was and they shadow in the labs. And so she said, I watch them and I can tell that they're a little frustrated and a little confused. And she goes, and I just keep telling them it's going to be okay. Just keep going. And I loved that perspective. That's why I love teaching this course. But I think, that is absolutely the challenge when we pull the rug out from under them. How much support do you give? And this is always the balance. How much do we help? How much do we not help? But we do that in our lecture classes. Again, lab is not unique in these problems at all, in my opinion. Anyway.
So I have so much questions I want to ask, but let me turn it over to the audience. Debbie Harrington, I think you had a really good question that was pinged out by a few of the people in the background. Do you want to unmute and tell us what your question was?
Hey, so I guess I agree that there are a lot of different goals for labs, and I think there can be a number of different goals for labs. But my question was basically, as a chemistry education community, is it possible to agree on some of the more important goals for lab?
I can jump in there. So when we all know here, when you look in the chemistry education literature, you won't be short of finding goals for labs. Every paper lists 10 or 12 of their own favorite goals. And this then becomes a problem. So there are reviews of these goals, and those reviews try and categorize all the lists of goals into kind of headline themes of goals. And then we have and it just becomes impossible to follow. And I suppose my reaction to this was to pare it right back and go, well, let's put it back to one goal. I think a lot of concerns I have about lab education is that labs are used to achieve goals because it's a favorable staff-student ratio rather than because it's an experimental environment. So I have pushed my one goal out there, Debbie. I mean, I think your suggestion is a good one. We need to prioritize what we think labs are for, cognizant that different students in different settings may have particular overall outcomes that they need in that setting. But surely we must be able to say what is unique about the lab environment, what can only be achieved there and not in a seminar room or not in a workshop. What is it about the lab environment that makes it unique? And that's where I try and make our starting point. And we've sort of built an entire curriculum trying to think about that as a starting point. That's an Irish politician's answer of not actually giving an answer, just saying a lot.
My politician's answer would be even more simple, and I would say I would ask my unit head, who is Debbie, for those of you who don't know. Yeah, I think that it should be unique to each department and maybe even unique to the course. I've been in departments where there were different general chemistry courses for engineering students versus pre-med students versus pre-nursing. So whoever the stakeholders should be giving input into that decision. If the people in the engineering department really want this set of skills coming out of their students, then that should be incorporated into the chemistry lab, because that's, I think that's how you make lab valuable for students and make it worth the huge cost, is make sure that whatever students are learning, they will be able to use as they move forward. It shouldn't be a one and done. This is the only time they ever need to know this.
Anything you'd like to add, Joi? Or
I mean, I just focus on the science practices. I felt like that was the doctrine that was handed down to us. Maybe I misinterpreted. I always go back to looking at that, and where are we, and that we are able to do those in a unique way, not only, I mean, obviously they can do data analysis and computational thinking in a lecture course, but in the lab, it can take on a different context, right? Because they're actually doing the experiment, they're actually collecting the data, they're actually, making mistakes. So, I don't know. I think, and I do, sometimes I'm go, wait, what are we doing? And I go back and I print those 8 standards out, maybe, and that's my real simple answer. I'm like, I was given a framework. So.
All right, we have another question from the audience. Clarissa Keene, would you mind unmuting yourself and asking your question? You had a very good question as well.
Hi, yeah, sure. So I think this is, I've been typing so much, but my first question was basically, I'd love to hear the discussants' thoughts on the roles different stakeholders or individuals play in creating the purpose and goals of lab. So thinking about, do you get the entire chem faculty department involved? Are you just talking to chemistry education faculty? What role do graduate teaching assistants and the undergraduate students themselves play in creating the goals or enacting the purpose of lab?
I think I could probably address that because I've been on this 6-year journey here. So I can tell you exactly how we did it. First of all, ECU hired me, and they hired me. And when I arrived, my colleague said, "When are you going to fix the labs?" And I was like, "Whoa, Bessie, not today. Let's take a minute," because it takes time. So I met with the lab manager, who I'll tell you was very defensive and made sure the chair was sitting in the room with me. And she told me I didn't know what they did and this kind of thing. She's now a big advocate, so that's fine. But there, it was a slow process, and I talked to her and I showed her things. I then gave a presentation to the undergraduate program committee. They said, "All right, let's give it a try." I applied for a teaching grant through the university that funded me to develop the curriculum for ECU over the summer. We then piloted, and I'm a big advocate of piloting, and there's lots of ways to do that. We piloted the new labs, and I won't go into the details of that, with just a few sections, with just a few teachers, and we got feedback. And then the first year that we rolled it out, and Katie Hosfine, my postdoc, is doing a big qualitative study, which I'm excited for her to get finished and published someday soon, on this whole transformation, because we've not just transformed the labs in chemistry, we've transformed in biology and physics and geology. So I can tell you this, there's not an intro lab at East Carolina University that's doing a cookbook, not one. So that is the culture that we have now. So it's not even questioned. But the several years that we were doing it, absolutely, the graduate teaching assistants were involved. Every lab, we said, what do y'all think? What should we change? It takes several years of tweaking, of changing labs, of getting feedback. So I mean, anything that's going to work well is going to involve as many people as possible, which makes it messy, makes it complicated. But yeah, so that's was the approach. Now, were the physical chemists involved? No, they didn't care. I mean, the people that wanted to come came. The inorganic chemists didn't come. Who came? Generally, the people that taught Gen Chem, the lab managers, and those people. So that's my 6-year journey. And I'll say this, and this I was going to say that at some point in this, now that we've broken the mold, the horse is out of the barn. I mean, this lab manager who sat with her arms folded, glaring at me, is now like, "Why don't we just do one big research project for Chem 2, and let's just do that? Why do we?" And I'm like, so. This is a system that's rigid, but I'm telling you, if we can just crack those walls a bit, I'm kind of like, whoa, because I mean, it's just kind of exploded anyway. So
I think your institution is very lucky that they have you and to seek out your help and your expertise. And I want to follow on one of the things that Sam asked in the chat about, should the literature and research guide us? And the answer is absolutely. And maybe I'm a little biased because I'm a CER person, but I think that yes, that we need to look at data and evidence to guide us. As chemists, we rely on evidence-based decisions. So when we're doing curricular decisions, there should be no difference in the fact that we need data to help make these claims. This lab is going to be better than this lab. And without that, then I think making those decisions is really hard. So to answer Clarissa's question, I think that at the minimum, you should have some of those people in the discussion be familiar with the literature, be familiar with the research, and be able to say, this is what is out there so far that can guide us.
All right, so as usual, I would agree with my two previous panelists, because that I would totally align with what they say. Certainly, so I have a very similar story to Joi. This has been a long-term process, and definitely agree with Brittland on the education research. One of the difficulties I find in the lab education literature is, in many cases, it's repetitive and not actually leaning on prior literature. I think there's a lot of people coming up with new ideas that are actually Old ideas just repackaged, and we probably need to do a little bit better as a community in bringing together our literature. In terms of, Clarissa, I think your question has been, or the idea of stakeholders has been very powerful in my own context. So we did two things very similar to Joi. Initially, I did ask sort of faculty generally, what do you want students in this program to be able to do at the end of their lab course, at the end of their 4 or 5 years? And that gave some ideas. So initially opening up the conversation to as wide a group of people as possible. I'm a physical chemist, and many physical chemists engage in this conversation. I reject any slander on physical chemists, Professor Walker.
I just said they didn't know.
Simultaneously, we reduced the number of people who made a decision. So we actually reduced the number of people who said, okay, this is what's going to happen, from something like 13 down to 4. And that, of course, then meant things could actually start happening. The student buy-in, both from undergraduate student and also for us postgraduate students who act as TAs, was vital. As Joi mentioned, this is, major changes, a multi-year process. And some of the years, you've got those faculty just waiting for everything to go wrong so they can go, oh, I told you so. So students sort of advocating change or saying, yeah, I think Brittland mentioned earlier that effective aspect of things, saying, yeah, we're enjoying this, we're having fun, we feel like we're doing things, is hugely powerful in keeping change going. And much of the work I've done has involved teaching assistants, so PhD students in chemistry, who act as teaching assistants, actually joining in on designing experiments or writing up articles and this kind of thing, because they know much more than I do about what it's actually like to teach a student in the chemistry laboratory, hour after hour every day. So that kind of stakeholder buy-in is really important and really powerful in keeping the train on the track.
So I'd like to take you guys back to question 2, since we've been talking a lot about students. So one of the questions we wanted to pose is, who exactly does lab? I know we talk about graduate students and undergraduate students, but what about those who are not chemistry majors? And then also, how do goals vary for different types of students, different student populations, even thinking about diversity and equity and inclusion issues?
Am I first?
Yeah, I think so.
Okay, sorry. This has been back to our 6-year study. I mean, this was an NSF funded project, and I'll tell you some of what's happened that's been disappointing was we have a huge population. I mean, we had 2,000 students consent to be in the research. Some of what's going on, and this is again something we are looking at, is those of us in chem, when we imagine they take Gen Chem 1, Gen Chem 2, maybe biology 1, biology 2, some of them are doing them together, and then maybe go on to physics. So when we laid out this beautiful research project, it was going to be, we'd collect data in Gen Chem and biology, and then we'd collect data in physics. So I'll give you the short version. In the fall of 2019, we had 639 students in Gen Chem 1. The following year in physics, we had 5 of those students. And they just aren't taking these courses in sequence. And this is something that has really captured my thinking. I am at a we have 50% first generation students. We have, a big mix of students. I think, and this is the equity issue I'm going to talk about, because I can't look at the equity issues in my labs because the pool just disappeared. We thought we'd have 2,000 students that we could look at, different groups. Well, they disappear over the 2 years. They don't disappear from the university, but they're not taking these. Sometimes they are taking Gen Chem 2 years later. And I think I've been pitching this, and I'd be curious what other people think. I think this is an equity issue, because We know that if you have students that are working and have families and working in multiple 3-hour labs into a week for a non-traditional student, well, you know, and I'm just postulating because this is the only explanation I can come up with, is that this is just it's too much that we're expecting. So in terms of actually being able to look at, you know, is ADI serving as a inclusive curriculum, we're going to have to move to a much more qualitative study where we're doing work similar to what Brittland's done, where we're interviewing students and talking to them. And I've done some of that, but you know, the idea that I was going to have this big, wonderful quantitative study with numbers and it was so happy, didn't happen. They're gone. They just like disappeared. So I just think the idea of the 3-hour lab in the curriculum for science majors is possibly an equity issue. So I'll leave that out on the table.
I think that is so provocative, Joi, about that 3-hour lab. And I know that we're going to touch on where is lab going, so I don't want to say too much about that now, because I do really agree with you that there are equity issues in lab. And a lot of that is drawn from that data, that interviews with students. One of the things that I noticed is that the students who feel the most comfortable are the ones who are engaging in the lab. And this was, I think the clearest example of this, I can still remember where I was when this woman told me this. I had just shown her, she was in a disagreement with her lab partner, and he said they should do it one way and she thought a different way, and she was correct. And I said, well, why did you decide to go with his way? And she said, he's an engineering major. He's really smart. I'm just a psychology major.
Oh, wow.
He's probably right. And so after the interview, I had to have like a talk with her, right? Like, you can make the decisions in lab too. But I was just so taken back by that. And I saw that come up again and again, that when people do not feel like they are in control of the situation or don't feel that kind of social capital, they will pull back and not make choices, not touch the equipment, not engage in the learning. And so this is actually something that I started digging into and found in the psychology research that this is a pretty well documented phenomenon, that people who are at of a disadvantaged group, or who are somewhat constricted in their privilege, will avoid taking risks. They will avoid putting themselves out there. And so I don't know, like Joi said, what would happen in an ADI lab, or if we move to something that is a more inquiry-based environment. But my guess would be that if you put everyone on that equal footing of being uncomfortable, of not knowing what to do next, of being in that like hard position, and make it more acceptable to say, well, maybe we're not 100% confident, and that's okay, that some of those students who have less confidence will be able to engage, because they'll realize that they don't have to be 100% sure to still take part.
And that's been my observation, Brittland. I mean, that, you know, anecdotally, when I observe students working in groups where nobody knows the right answer and I'm not telling them, that you do get, I think, people that might not normally engage to engage. Everybody's voice suddenly matters a little more. So.
Yeah, it's really interesting. I mean, I suppose on that point, I think part of my problem with the Cookbook lab, and I think they're over stereotyped, but nevertheless, if you just take the classic stereotype of the Cookbook lab, is that it does produce this sort of, there is a right answer and you can either get there or you can't. And if you can't get there, well, then you're a failed chemist and you shouldn't be doing chemistry. And I think that's a real problem with that kind of approach. On the general question, I suppose I don't have much to say, because I'm most of my work is with card-carrying chemists who sign up to chemistry on day one. But I do feel, I mean, this is more about school chemistry in the UK. I do feel about, how many tens of thousands of students are passing through a Gen Chem lab. And if we could use that to invoke some sense of the tangibility of chemistry and the role of chemistry in society, and the understanding that scientific processes or data has experiment behind it, and there's a sort of a nuance to that, just some more broad aspects to educate these citizens of society rather than to educate people into making a 0.1 molar solution. It does seem to be a lost opportunity there. But I mean, that's just from me personally, my own soapbox. I don't have anything more intelligent to say on that, Nikita.
There was another comment up top. I don't remember who said it. I wanted to thank them about making lab more accessible. I think there are some things like broadly that we can do like philosophically in lab to make lab more accessible, which is sort of the level we've been talking about just now. But there are also concrete things that we can do to make lab more accessible, even when they are cookbook labs. And there are some companies that offer technology for that, accessibility technology for students with blindness or low vision, or I mean, if you search for it, there are solutions out there, but they have to be something that you're like ready to implement. There's another one that I just saw from company Alchemy, that they're making these model kits that they work for sighted and students with blindness, and it's meant to be the main kit. So everybody gets this kit, but then it has these adaptive features that are built right in, but it's designed so that you don't have to go out and get something different or teach the instructor how to use this in class instead. So there are things out there that can be done, but you have to kind of hunt them down.
All right, so moving along to us looking at question 4. So how do we know students are gaining, whatever types of goals or whatever things we set forth for them to do inside of their lab work? How do we know that they gain those things? How do we then try to answer that question?
Why am I first again? I talked too long. Michael, you go first.
I was just going to copy you.
No.
Well, I suppose, I mean, the three of us have been, I guess, heavily involved in researching whatever our particular interests are in labs, and obviously across the board, there's a huge amount of chemistry education research going on. So like Joi, I do balk a little bit at the idea that, I mean, Hofstein and Linetta updated their review, I think 25 years later. Their main argument is that the lab's not a good place to teach chemistry, as in chemistry content, and we are too reliant on Cookbook. But I mean, I think there has been amazing innovation in labs and lab teaching over the last few years, and an understanding, and I will point to Brittland's work if she doesn't mind, an understanding of what's going on in labs for students. I mean, it's just, we do just know so much more, certainly about the challenges and the issues that are arising. I mean, I am not very good at keeping up with chat, but I have seen a few chat messages there about assessment and so on, and how we know whether students are gaining those things, not from a research point of view, but from an assessment point of view, is probably something that still needs, certainly from my experience and where we are, work. We still rely on a lab report most of the time. We're trying to bring in more dialogue and that kind of thing, but it's still very monofunctional. You are going to be an academic and you are going to write a paper, and this is sort of your first step in that journey. It's so I would like to see more diversity in assessment, and perhaps that's a way. I mean, that's why I like Joi's work, where she's bringing in different forms of assessment and different ways of eliciting understanding from students as to what they actually know. So, I mean, I know there's some literature that says, well, we don't know what's going on in labs. We need to be able to prove learning is happening in labs before we can, or if we want to continue using them. And I think that might be a bit of a straw man. I don't think we're ever going to get this sort of panacea where we know learning happens in labs. I think it's so dependent on what goes on in individual labs, what the goals of those labs are, or what the people interested in students achieving in those labs are. I think it's just going to be much more granular than students did this survey and then did it again a while later, and then that meant they learned something. I think it's too complex a setting for that.
So we published our Gen Chem assessment, Gen Chem 1, General Chemistry 1 assessment in JCE this semester, this spring. So we do a lab, I don't know what to call it, it's a laboratory practical exam. Students come in, and so one of the things that probably a lot of people don't know about me is that, I was a professional chemist. I worked as a forensic chemist. I worked as an environmental chemist. I was a professional chemist for my first career. This is my third career, for 10 years. And so I'm very much at the end of a general chemistry semester, I ought to be able to hand a student a bottle of acetic acid and say, go, tell me about this. Tell me, we don't send them, it's not the Wild West, and so that's the idea. That was my thinking way back 10 years ago when I began designing these assessments, where students actually came in at the end of the semester and conducted, and for Gen Chem 1, it's a titration, and they titrate on their own. I was assured by everywhere I've done this that the students could not possibly do this. The students somehow didn't get that memo because they do it fine. They come in, they do it. And I have always been amazed when they leave. I have literally had students thank me and say, thank you, that was really cool to come in and actually do it. So that assessment is published. We've also got one for physics that's published in a PER journal, and we've got them for biology as well. So that's one of the things we do in terms of assessment. And these are very much based on the science practices, that from the framework, are designing an experiment, engaging in data collection and analysis, doing mathematical reasoning. But there's constant formative assessment, and even the work we've done in videoing students engaged in argumentation. That's not a grade that they get, and I'm nervous now because Michael said that the same stuff gets published over and over, because I'm fixing to publish my third paper on student argumentation videos, but this is the last one, I think. And but we absolutely see that students can engage in argumentation and that it improves over, Katie presented this at JAWS, that it improves, they get better, and the videos, when you watch those videos and you watch, what I watch is the student that's the presenter. So in the ADI labs, there's a student that presents the group's results. They present it, to traveling people, just like a poster session. The third time that student presents that information, it is so fabulous, right? So I'm always like, how do I grade that? But I see it, but I do see it. And we've, like I said, I've watched way too many videos and analyzed them a lot. So, I mean, I think, assessment can be happening by what they're actually doing, but, I also think you can give good exams, open-ended practical exams where students go in the lab and do something, and we can expect them to do that.
I think that people are probably not going to be very pleased with my answer on this because it's so connected to that first item that we talked about, which is what are the goals for lab? And I just want to say, often you hear this is a judgment-free zone. I do not judge your lab goals. Whatever your lab goals are your goals for lab, and you get to pick that. And however you assess those, it just has to be aligned with your goals, right? So whatever your assessment is, as long as it's aligned with your goals. And this reminds me of a question that my kids ask me all the time. because now we're home all the time. And so they're hungry all the time. And those of you with young kids will know this, that like when they're bored, they're hungry. They don't know the difference. So they'll ask me, and they know that the answer is always like, yeah, you can have a healthy snack. Is this healthy, Mom? Is this healthy? And depending on the object, right? If you've got like a piece of whole grain bread, is this healthy? Well, it depends on what your goal is, right? Are you gluten intolerant? Or are you, an athlete trying to consume calories? What about cheese? Is this healthy? Well, do you have a calcium deficiency? Are you have high blood pressure and you're trying to cut out saturated fats? Like, it depends on your goal. You cannot answer the question, how should I assess this, until you have your goals clearly delineated. So if your goal is to have students present their investigation as an argument, then you're going to evaluate that argument either orally or their written arguments. If you want your students to work together, then you probably should have something like CATME to evaluate how they're functioning as a group. If you want to evaluate their technical skills, and I know this is something that Michael does a lot of, is having badges where you have them do the technical skill and evaluate that skill. So you have to figure out what goal you want and then make sure that your assessment, whatever your assessment is, matches that goal. If you are thinking students have to be able to independently come up with an investigation, then evaluate how well did they meet the criteria for this investigation. Were they able to isolate variables? Were they able to focus on the most accurate way to take these measurements? Do you want them to work independently? Because if they do, then you better be evaluating them independently, right? So these are all of the factors that you should consider when you're thinking, what kind of assessment should I have? And assessment doesn't always need to be summative either. I mean, when we're thinking about a lab report at the end of an experiment, or we're thinking about a practical at the end of the semester, it could be something that the TAs are trained to do and collect information on in lab. There are some observation protocol. Maryland Stain has one that's specifically for lab. It's actually for observing students and TAs in the lab. But I mean, you could have your TAs trained to be evaluating how equitable is the division of labor in the student groups, which students are asking questions and which ones are not. Those sorts of things. You can evaluate the quality of the lab experience in a lot of different ways. You don't have to just stick with sort of the traditional lab report and then maybe a lab practical at the end of the semester.
Hear, hear, Brittland. 100% agree.
All right, so I'll take us to the last question and then we'll open it up for some discussion amongst the attendees. So where do you guys see lab going? Do you guys anticipate any transformations and changes to come?
Joi, do you want to take that one?
Okay. Well, again, speaking back to what I was saying, it's like, the horse is out of the barn here at ECU. We're redoing the organic lab. I see, and at the same time we got the grant to do the intro labs. We also got a grant to introduce cures. I am very intrigued, and I love hearing Michael talk about his model where they move into research, where students move into doing research. And so we have cures up and down the curriculum. I watched some of what's happening here. And for example, I'll give you in our instrumental analysis lab, the instructor there had always sort of let the students pick some problem to do. But now what they're being able to do is, because they're coming from their cures, they're saying, can I keep, we let them keep working on their research in the instrumental analysis. So we're seeing this within the chemistry curriculum, this access to research, which is to me and everybody that writes about cures, this is a significant equity issue. You've got to be a student that has time and extra time in your schedule, extra time in your life, and possibly extra money to pay to take extra independent research courses. But if the research can be embedded right in the chemistry curriculum, which is very much what's happening here at ECU, not just in chemistry, but in biology, geology, and engineering. So my personal goal, that's my personal goal, and that is to see labs move towards more research experiences where students are working on something that they maybe have more ownership of and are able to keep continuing. It builds throughout their time here in their courses. I certainly hope that we can move to fewer cookbook labs, just these heavily scripted labs. I have a Google Drive that I'll share with anybody that has all the resources to implement my lab curriculum, which is, just one. There's cooperative chemistry with, Justin Carmel and Melanie Cooper. There's science writing, lots of people science writing heuristic and POGIL. There's a lot of lab options out there. And I just would really encourage people to not be so intimidated by the change. It's not a heavy lift. It's not as heavy a lift as people think it is. Once you kind of crack the seal, anyway. And that may just be me. I know I'm bossy and told everybody what to do, but that's just too bad. They did it.
Brittland, do you want to go next, or are you?
I will. I feel like, so I'm kind of in a following up on the pandemic kind of mindset here. And I try to be an optimistic, positive person. And so always looking for silver linings. But I'm not quite as optimistic as Joi that everyone's going to be able to make such a radical transformation of their lab. What I'm hoping is that people will look at what they've done to sort of get through this academic year in the labs and evaluate, what did we have students do when they couldn't be in lab? And what of this can we either move to the lecture course or get rid of from the lab course, because lab is too expensive and too precious to be wasting time with things that we can have them do not in lab. And how do we focus on what is the most essential things we can get them to do in lab without having, lab be another place where they practice this algorithm that we taught them in lecture a bunch of other times. So, and maybe there are places where we do move to more virtual access to the ideas that we have in lab. Maybe there could be places where students are planning experiments but not carrying them out. And I think that this goes back and ties in that accessibility thing. Like Joi was saying, not every student can take 3-hour credit course or three hours a week for a 1 credit course and invest that much of themselves to do a lab. So maybe we make lab more flexible by having some virtual experiments or remote experiments, or looking at other possible ways to get these same things, same learning objectives accomplished, but not with the physical presence of students being in lab. Is there still going to be students pipetting in lab? I hope so. But I think that maybe the pandemic can challenge our idea of which parts have to be done physically in the lab and what parts can be exported to other physical areas of being.
Yeah, I think I'd echo a lot of that. I think I'm also in pandemic mindset, and I think the year has been very challenging, but has prompted a lot of people to think about, well, why are we doing this in the first place? If we have to replace this 3-hour in person with something online, it's really got people thinking about, well, what does that 3 hours online look like, and what was the purpose of it in the first place, which has been very exciting. It's been very tiring, but very exciting. So I think we will see moves away to, well, actually, if some virtual reality or pre-lab planning can be done separately to the actual technical work in lab, well, then maybe there's opportunities there. But I think somebody mentioned in the chat earlier, I mean, one of the obsessions here in the UK and Ireland was, what will the professional body think? Okay, so our professional body says you have to do 400 hours of lab if you graduate as a bachelor's scientist in chemistry. But it doesn't say what that 400 hours should be. It's just lab related work. So technically 400 hours online is 400 hours lab related work. And suddenly the fallacy of this whole stipulation was just blown apart. And I think, and I need to be slightly careful with what I'm saying, but screw it. I think the professional bodies really need to step up here and work with the community, work with people who know what they're talking about, chemistry education researchers, chemistry education practitioners in labs, and determine, certainly for chemistry majors, what kind of things we should be building into lab programs that are inordinately expensive and take a huge amount of effort to run and are hugely valuable for students. What should we be doing? Can we come up with some consensus? So the kind of things we've been talking about all through tonight. I really think professional bodies need to move on from not necessarily dictating what every single hour needs to be, but move on from just saying X number of hours, full stop. It's just not acceptable. I think in that knowledge deficit, all the trouble we have with lab education is emerging because everybody has their own idea of what a lab should be. So I think there's the fact now that this kind of idea of, well, what do we do? What are these hours meant to be? Has sort of the cover has been blown on that. I think a lot of questions will start to be surfaced. Certainly they are being here in terms of thinking about, well, what kind of things should we be doing? So that's my hope. But I mean, we all know change comes so slow in education, and we'll probably be here in 20 years' time talking about cookbook labs. So we'll see.
Oh, stop.
I mean ADI and this really old-fashioned thing called ADI.
I'll just chime in on that. That I think our faculty, because just not to be ageist or offend anyone, but the faculty that were most at risk taught the online labs, and they really enjoyed it. And really, I was glad I was sitting down when these two guys said, these labs are really great, Joi. I mean, so what was the only thing that was missing was the students actually collecting the data. We gave them, I made all sorts of crazy data. I actually pulled data from old students. The students still worked in groups. They broke off into, breakout rooms. They did their PowerPoints instead of a whiteboard. They did their argumentation. We had all of those components. And so absolutely, this is something that I'm in conversation with my chair about, primarily because of my concern about access and equity with just scheduling, is how maybe they only need to come to lab once a week for an hour and a half and collect their data. And then they can do, the group work online. I don't know. We're thinking about a lot of those kind of things. And I love you pointing out, the 400 hours can be, because ACS requires that too, right? So.
All right, so we'll open it up to questions. Rachel Driscoll, do you want to unmute and ask your question to the panelists?
Are you asking about the limit question, my latest one?
Yes.
Yeah. So yes, I think that if we're in agreement that there is something special about lab time and things that we can, and making sure that we use the time that we have in lab effectively, is there then a limit to the amount of flexibility that a lab course can offer? I think those are great ideas of flexibility and equity, meaning, okay, can we outsource this to time outside the lab? But then that's in tension with, okay, there are things that we can only do in lab. So any thoughts on that tension or where that limit might be? Is there such a thing as a limit to the equity that can actually be met in a chemistry lab. Does that make sense? Like, I hate to ask that question, but I think it's a relevant one.
And I think that's something we've got to think about. I agree. I mean, you don't want, so again, if some students are only in the lab an hour and a half and some are in longer, then that's, you know, that's also an equity issue. So it, yeah, I think, you know, that goes back to our original opening statement that Brittland started with, is defining what we want them to do in lab.
Okay, we had, oh, sorry,
Joi.
go ahead.
Exactly. Maybe your lab goals do not require students to be in lab. It just would depend on what the specific goals are.
Yeah.
We also had another good question from A. Russell. Do you mind unmuting yourself and asking the question?
My question was, how do we justify chemistry lab as opposed to a biology lab? I know some people said they don't have biology or a physics lab, because at my institution, chemistry is by far the most expensive laboratory of the physical and life sciences. And if we are teaching scientific practices, why us and not the other departments?
Michael, this seems kind of like a history question. You want to take it?
So Ha-Seok Chang has a lovely paper on this, where he talks about chemists as the identity of a chemist is very much about the doing. He says chemists are makers. I'm not sure about the US context. Here, physicists, biologists, and chemists all do labs in their early years. It's an experimental science in all three cases. So I'm not sure why they're not doing it in those institutions. But again, I mean, I'm coming around and more, as always, aligning with Brittland. I mean, it's essentially, well, what do we want these courses to do? And in chemistry, as I mentioned in my opening comments, it's just intangible. The sense of doing labs is just part of being a chemist and doing chemistry. And even if it is pipetting, buretting, and so on 10 million times over, that's what we identify as doing chemists. So I would ask the biologists, why aren't they, rather than the chemists, why are they?
I think that some of it is beyond our control too, right? Most of my students don't take my chemistry lab because they're going to be chemists. Most of my students are coming from engineering, or they're pre-med or pre-nursing, or those programs dictate which courses and which labs they take. So I think that goes back to allowing stakeholders to have a say of what do they think that is so important for their students to get out of chemistry lab? Why are they asking their students to take our courses?
So we offered intro biology and physics, and I would think that the biology labs were probably close to as expensive as the chemistry labs. Physics, you know, I mean, they're rolling the same ball down the plank every week. So no, I'm kidding. I mean, they don't have any waste, right, that they're dealing with. So chemistry has to deal with that. I had written this down earlier, and this goes to the point, and this is me putting on my science education hat. I think there is a role for science literacy that we can play. And yeah, we've got pre-meds and pre-nursing, ain't a one of them in med school or nursing school yet. And the odds of, you know, and what, 4% of them will be. So because, you know, my PhD is in science education. And so I really embrace the role of chemistry lab, if it's the one lab they all take, of an opportunity for us to provide some, you know, science literacy, understanding of the nature of science. And maybe understanding big societal issues, or at least understanding the tenets of the nature of science and when they leave. So I guess, Arlene, I don't resent being, the one lab and the expensive lab. We do, we serve a big population, and I think this goes back to, if we maybe recognize that, and that this is a chance for us to provide a more general population, not, the UK doesn't have this because they apparently have card carrying chemists, which I'm intrigued about that. But just embedding science literacy, giving, and which, obviously you need to stop doing cookbook labs, because all that does is make people think there's a right answer every time they show up. And so, that's my perspective on, maybe being willing to take one for the team, with everybody taking Gen Chem 1, at least all the engineers.
So here, I guess we'll open it up. You guys can raise your hands inside of the participant list, and we'll call on you. But I do know Susan Hester had a few questions. If you want to unmute yourself, you can go, and then we'll just go based off of everybody's raised hands.
Hi, thanks. I guess the question that is the most recent one is, it's really interesting to hear you talking about some of the affective outcomes and engagement outcomes that you've seen, both kind of anecdotally and in some of your qualitative research. And I don't know if you had the headspace and bandwidth to look at this when you did the remote adaptation, but especially Joi, it sounded like you did a really good job of adapting your lab for the remote setting and are thinking about how can we carry that forward to increase equity. Do you have a sense for how those affective outcomes were impacted by the remote versus the in-person experience?
I don't. And just primarily, I just refused to try and do research during a pandemic. I was like, no, I will not. So, but I think that's a great question. And if we do implement or maintain some of this online capacity, it's certainly something to look at. Yeah, thank you.
Thanks.
We didn't study anything during the pandemic per se. Hand waving online labs were just difficult for everybody for all kinds of reasons. So it was hard. It would be hard to sort of compare like with like, which I don't think you're suggesting. But I think in terms of looking at this moving forward as sort of something separate or something different, all kinds of issues emerged on the difficulties of interactions that, no interactions or that kind of supportive lab partner or teaching assistant or whatever. All those kind of things disappeared for students sitting remotely in their bedroom. All kinds. So we have been looking at student feedback and so on. All kinds of just simple questions that students just wanted to check suddenly became this big drama that they'd have to figure out how to ask and so on. It just became really challenging. So I do understand that there's an interest in looking at this kind of idea as an alternative from an equity point of view, but I think it itself raises so many equity issues. I'm not sure it'll be panacea in terms of dealing with that, but I guess I don't have anything formal apart from the year's experience that we've all had.
I would caution anybody from drawing conclusions with what happened over this year, comparing it to, we've optimized over the course of 5 decades and all of our instructors know how to do this and we know how to make it run like a well-oiled machine. All of a sudden, everyone's new at this. Everyone's dealing with all of these other pandemic-related issues that are outside of their job or their school. So I would say it's not really a great place to make a comparison, but there is excellent literature out there about virtual learning in the laboratory and in the chemistry laboratory. And if I don't have it on me right now, but if you want to message me or email me, I will send some of that your way about the studies that have been done. And it turns out that the learning outcomes, whether affective or cognitive, are pretty comparable, depending on what type of, if you do a cookbook lab in the lab versus online, it turns out to be pretty the same. So yeah, I can send that to you if you want.
Yeah, thanks. Yeah, I was particularly interested with the inquiry labs because I know the affective part is such a big chunk of what students get out of it. But that's a good point about pandemic life.
Vincente, go ahead.
Yeah, Vicente.
I guess that I want to go back to Arlene's question because I am kind of concerned in a good way that the message that I heard is that, okay, our chemistry labs, and I'm not going to talk about labs for chemistry majors. I'm talking about the labs for science and engineering majors, Gen Chem, OChem, that are taken by many students and are taught by many instructors. I'm concerned with a message that says, okay, these labs are very good at developing science practices or should be focusing on developing science practices. The learning goals should be set by the people that require those labs, that are the pre-med, pre-nursing, etc. And I said, okay, then why are we teaching these labs? Because the reality is that science practices can be developed in any context. And maybe it would be better to develop them in an interdisciplinary context. So why don't we get just rid of the gen and the biology and the physics lab and we have science general labs? And how do we sell that we chemists should be the ones benefited? We benefit from having so much money thrown to us, to pay for TA-ships and to teach our labs, particularly in public universities. So I'm ending this webinar and saying, okay, if someone asks me why should we chemists be the ones that benefit from teaching the labs, what is the answer to that question?
I would say that the chemistry knowledge that underpins biology justifies having people whose expertise is in chemistry. And I would just point to the language that my biology colleagues, I love them, but the language that they use about ATP and ADP just drives me crazy. And so I think that as chemists, we can offer a chemical perspective on biological things. One of the biggest learning goals that I have for my my pre-med or biology major students is about intermolecular forces. And I think that our chemical perspective on things like IMFs or energy is just, we use different language and give students a different perspective on those phenomena that they get maybe more of a holistic or general sense of in biology, but don't get that mechanistic understanding.
Well,
I don't have anything to add. No, sorry. Go ahead, Nikita. This is
no, I
wonderful.
just was going to ask you guys for your concluding thoughts since we're coming up at the end of the webinar.
My concluding remarks would be to not be intimidated by trying something different in the lab. And to realize that there is research out there. There's a lot of good research out there, but I think, and to just have a good conversation about what are we doing? And I think so many good points have been brought up, and you can always go back to, I mean, the first question I ask the students in my TA course is I play devil's advocate. I'm like, what are we doing? Why are we doing this? This is expensive. It's expensive in time, money, personnel. What are we doing? Why should we ever do this? And, you know, they kind of freak out because that's not what they expect me to do in this course. So it's fun for me. But I think that's a place to really maybe think about it with whoever you're having these conversations with. And I think all the points have been really good about that.
I will agree with what Joi said and go even farther and say, not just question what we're having the students do, but have that intentionality about everything we do too. Why do we do a pre-lab? Why do we have them turn in a lab report? Why do we ask them to work in pairs? Maybe there are things that are driving these that aren't tied specifically to learning goals, things that are, you know, realistic, like we don't have the number of materials for students to work individually, but we should at least have a reason for why we do what we do. So intentionality, that would be my last word.
Yeah, I think I'd echo all of that. I think dialogue in your department or with people who are interested in labs. We talked about stakeholders earlier on. If it is to change things, but also if it is to see how things are going. I mean, students and TAs and people working face to face in labs will tell you a lot if you make time to talk to them. I think there are opportunities that have emerged from the pandemic that will see a lot of those conversations. I do worry a little bit that people will be wanting to rush back to the way things were before, just because, oh, it's so much easier and let's just not worry about that last year ever again. And so there's going to be some sort of window of opportunity where people might be willing to talk about things. So seize the day. Since none of us are going on any conferences this year, this summer is a great time to seize the moment. But yeah, just I mean, my final thoughts are, as always, in listening to others, just talk about labs. You learn so much yourself, and it just challenges your own thinking, and just about continuing those conversations anywhere we can.
Well, I would like to thank my panelists so much for being here. This is my first webinar hosting, so I had nerves on. But thank you guys so much. Again, Joi, congratulations on your tenure, promotion. Woo, woo. And this webinar was recorded, so it will be available for you guys to watch on demand. So thank you guys so much, and keep calm, carry on, and try new things in lab. Thank you.
Thank you, Nikita. Bye, everybody.
Bye. Good to see you.
Bye.
Thank you.